Hello, welcome everybody. It's a great pleasure to talk to you here. Yeah, and let's start with the title. So, From Here to Eternity. I seriously hope that some people here are remembering this name from Iron Maiden song, which is really good. But if not, I hope that some of you think about this old Polish joke explaining the space and time relation. You know that one? When you dig a hole starting here and you end in the evening. No? Come on, I tried. All right, so surprisingly, I'm not going to talk about neither the Iron Maiden song nor the old Polish jokes, but I cannot guarantee that there won't be any. I will talk about creating applications to last. So this picture, which you can see on the first slide, is not here by accident. It's a picture of a sculpture of David by Michelangelo in 150s. It was created in 150s. And if I'm calculating this correctly, it's over 500 years now that it was created, and everyone knows it, right? I hope. And I hope you can see it, yeah. So I kind of think that we, as people connected with software development and running software in the cloud, are kind of an artists, or at least craftsmen. So I think that we want to create our applications to last, and we want them to be remembered. For example, this is the website that I'm using when I can't remember the network masks and how to calculate them, because I know that everyone does it in memory, but I don't. And I've been recently using it. I used it last week, and the last time that it was updated was 14 years ago. And the person who created this application is very lucky because he, she, I don't really know, can create a single deployment once in 14 years, and the application is working correctly and people are happy because they're using it. But right now, in this cloud age, we're having so many changing and so many rapid changes in our requirements that we're not going to create one deployment in 14 years. We're more likely going to create 14 deployments a day or even a minute. Or not a minute, an hour maybe, yeah. So before we get to straight to the topic, let me tell you a few words about myself. My name is Wojciech, and I'm working as a senior DevOps engineer at GoodLuck. I've been working with CI and CD systems for most of my career, and lately I'm working on cloud-directed and cloud-based solutions. And GoodLuck is a company which has been for over 8 years in business of cloud, SDN, and DevOps. We have a main office here in Warsaw, but we also have an office in sunny California and in beautiful Gdańsk, where I come from. Yeah, and let's go. I'm really surprised that it's been over 2 hours now that we're here on this conference and no one has yet told that the cloud doesn't exist. It's just someone else's computer. Well, obviously, it's a joke. It is. It's a joke, yeah. You can laugh. No, don't be afraid. But as with all jokes, there is a grain of truth in it, right? Because after all, when we're using cloud, we're just lending someone else's computing power for our own needs. But cloud, obviously, is so much more than that. But when the cloud revolution started, people just started moving their own infrastructure to this cloud land, you know, where you just didn't have to manage the infrastructure, you didn't have to worry about it, you just had to pay for it. So basically, when the cloud became common, people or organizations started calling their applications cloud-enabled, which meant that they were not hosted on their own premises, but in the cloud, which should, by design, give you more reliability and so on. But it turns out that it's not enough to move your application to the cloud to, you know, be cloud native. Because cloud native means that you're using a lot of features from the cloud, not only the flexibility, not only the cost optimization, but you're also making it easy for yourself and for your teams to manage the application. So cloud-native applications are focused on availability, on ease of maintenance, to bring a lot of value to the business. But obviously, as I said, getting from being cloud-enabled to being cloud-native is not easy. So there were a lot of guidelines, there still are a lot of guidelines which are trying to help you achieve this state. And in my opinion, one of the best ones, the most concise yet containing a lot of information, is called the 12-factor apps. And as you can see, it was created a long time ago in 2011. Some people would say that by now, I'm sure that everyone has heard of 12-factor apps. Is it true? Who has heard of 12-factor apps in here? Okay, so I can see that some people didn't hear about the 12-factor apps, or just too lazy to raise their hands, or didn't have a coffee, so they're not awake by this time. Okay, so I will continue assuming that not everyone has heard of the 12-factor apps. So it was created by engineers of Heroku. Well, you know Heroku? You know what Heroku is? Who knows what Heroku is? All right, I'm not going to do this anymore. I see you're tired already. Well, Heroku was one of the first, if not the first, platform as a service solution, which offered you to just upload your code and run it in someone else's environment, basically. Well, of course, for a price. But the price that you had to pay was obviously lower than paying for the whole infrastructure. So the engineers from Heroku have seen that people are starting to use Heroku more and more, but actually they don't know how to create their applications to work in the cloud. So this was sort of manifest which was explaining how to make your applications cloud native. It's really essential for software as a service market because you want to create revenue based on your software, and you want to be able to not worry about the infrastructure. Just as you could hear on the previous talk, on the keynote, people don't want to worry about the infrastructure. People want to worry about the software. This is how you can do it. So basically, cloud-native applications try to make their setup and maintenance as easy as possible. We want to make sure that we have some sort of manifest, some sort of declaration of how your environment is going to look, and we do not want to worry about how to make it happen, right? We want to use some tools and just tell them, set this up here, copy this file here, make it run, and we want it to happen. Moreover, we want to be able to deploy our application in different cloud environments if we want to, switch the vendor that we're using. For example, you can go from private to public cloud, and you want this transition to be as smooth as possible. And since we're talking about creating real business here, we want to scale our application up. We want to be able to, handle a lot of traffic, handle a lot of people, because, well, since you're creating an application, you obviously want people to use it, right? And the worst thing that can happen is this VCOP effect, when your site just goes down because people get to see you get to see your web page and it dies. Right. So before we get to the practical knowledge that we can take from the 12-factor apps, and since not everyone has heard of them, I will try to explain the basics of the 12 factors. But I have to say that each one of those could take a book to explain. So I will just go roughly through all of them so that you can see on the examples how they apply actually in real life. So the first one is code base. And you want your application to be contained in a single code base and versioned in some kind of source code repository, most likely Git, as it's the most popular right now, but it doesn't matter which solution you choose. It's important to have one. And also, I don't want to start the holy war about monorepo and multiple micro repos here, because it's not really important. Whatever works for you and your application is good. Just have it completed. Second thing is your application should have explicitly declared all the dependencies that it's going to use. Because I know that it's hard to believe, but there are servers which do not have curl installed. Or at some point, your application might not be running on Ubuntu, but on CentOS, and so on. So if you didn't say that you're going to use something, do not do that. And together with this, it's important to have a configuration which can be injected to your application at runtime. And the good idea is to store it in the environment. By environment, I do not mean that you have to use environment variables. You can use some sort of key value store that is specific to the environment you run in, and so on. It just means that configuration of your application should be set apart from the build of the application. And whenever you create an application, I'm pretty sure that you're going to use some sort of backing services, like databases, some message queues, and so on. And for the 12-factor apps, it's very important to treat them as backing services. And as such, you have to treat them as an attached resource. And if it's attached, then it can also be detached. Then it can fail. And failures of the resources should not, of course, shouldn't affect your application as much as it's possible. This all actually combines to this fifth point, which is build, release, run. And it means that once you build your application, you should never have to alter your build to run it in a different environment. So you start with a single artifact. It can be a container. It can be a package. And to deploy it in a different environment, so to release it to another environment, all you have to do is fill it with some information about it. So environment variables pointing to external services, and so on. And at that point, you manage all the environments similarly, just based on differences between the services in them. About the application itself, the system that you're building should be composed from one or more stateless processes. And what is really important, your application shouldn't try to manage those processes. You should always try to give this responsibility to the platform that you're running your application on. So to explain how it works, if you're running an application on a typical virtual machine, you're going to want, for example, systemd to manage your application. I see that someone loves systemd. So yeah. For example, you want systemd to run your application, and if you're using containers, you want Kubernetes to run your containers, and you don't want to worry about, for example, replicating your service and so on. Together with this, we have this port binding technique, which means that each of the resources, each of the services in your system should be available over the network at some port if it's going to communicate with others. This is pretty basic. And to be able to scale and not worry about the application itself, the processes should be able to run concurrently. And this is really important because if you're running applications in the cloud, you have to remember that the typical model of scaling in the cloud is horizontal. So you're not making your containers run with bigger resources. You want to make more containers to handle the same traffic, I mean, the increasing traffic. So if your application cannot run concurrently, your processes cannot run concurrently, you're in for some bad time. And to be able to scale effectively, you have to make sure that your processes can be started up really fast and can be shut down gracefully. Because in the cloud, there are only two things that are for sure. One is changes, and the second one is failures, which lead to more changes. So if your application cannot start up fast, you won't be able to handle the traffic increasing very, very fast. Remember, Reddit effect, Wacom effect, and so on. And if you're running some, for example, if you're running some event-based system, your processes should be able to, let the system know that they didn't finish handling the data, and you don't want to lose anything. So you want your processes to be able to stop gracefully. All of this essentially leads to parity between the development and production environments, and actually any environment that you might want to run your application in. And what this means is that wherever you run your system, you want to make it as similar to other environments as possible. And here, software developers might want to say that, okay, so I'm writing this application in Python, so I know some libraries which can handle many different databases, right? So I can easily run my development environment using SQLite. Then I can run MySQL cluster in a QA environment, and then want to use Cloud SQL in the production because it's a managed solution and I don't have to care about it. Well, it sounds like a good idea, but obviously it isn't, because all these database engines are much different from each other, and anything that can happen on a local system can happen in a very different way in a production system, and you don't want to be surprised by this kind of things. So remember, keep the environments as similar as possible. The last two things are more for the operations part of things. So first of those is number 11, the logs. And if you're a developer, sometimes you might be thinking, I will make my application handle its own logging. My operations team will be very happy because they don't have to care. Well, being from the upside of things, this is very, very wrong. We actually want to care about the logs. We want you to not care about the logs because you don't have to explicitly know how the environment is going to work. We want to be able to, get all the logs from all the applications to a single point to analyze it and to see what's happening in our system. And any other solutions are most likely going to be a pain in our deployment. And the last thing is admin processes, which means things like database migrations and so on. And what this basically means is that all the 11 steps from before should apply to our admin processes. And if we have to run a database migration, we want it to be versioned, we want it to be configured properly for the environment, and we want to see the logs of it. This is it. This is the 12 factors. This is like the basis for creating the cloud-native applications. So since we know how the theory goes, I suppose that everyone is aware that in theory, there are no differences between theory and practice. But in practice, there are. So I would like to talk to you about 3 kind of stories that are covering the changes between the theory and practice of applying 12-factor apps to your systems. And the first one that I'm going to start is something that is, I suppose, very common, and a lot of people have seen this situation, and it's containerizing a legacy application. Because, after all, the cloud is for containers. So imagine this. You're sitting by your desk, it's Monday morning, you're having your coffee, and then your boss or your client comes and tells you, all right, so we have to move this application to the cloud. This old legacy application that you want to forget about, but it's there, and you have to maintain it. And you have to move it to the cloud because it's the last one that's left. Everything else is in the cloud. But not only this, you have to make sure that this application is containerized. So you don't have a choice, but you start to think about how to approach this. You're one of those lucky people who actually have documentation for these kind of things and have actually tested that you can run a new instance of the application. It's going to work according to the documentation. So let's just say that you're this lucky. But you're analyzing how your application is built. And you can see that there are multiple components of the system. They are really tightly coupled. And obviously, it's a big Java monolith application, because why not? And you have to migrate it somehow. So you start to think. And you come up with a brilliant idea which is going to get you this work done by the end of the week, and it's going to containerize your application and run it in the cloud, which sounds perfect. These are the 3 things that you were asked to do. So you decide to just run some sort of process manager inside the container to run all of the components of the system together and just pack it up and move it to the cloud. This gives you this, the monolithic container. Something that everyone despises, I would say, but unfortunately, this is sometimes this is the thing that happens. So let's have a look at it. So we're having a container with multiple components in it, and we just, we do the port exposing, right? So we expose our application somewhere, and it's available, and you can use it freely. But is it really good? Well, first of all, you're running multiple processes in a single container. This is wrong, actually, on so many levels, but I will go with two. The first one is, this is not what the containers were designed for. But if you do not want this idea, if you do not care about what the container was designed for, let me tell you this. You don't want your application to manage your processes. You want the system to manage your processes. Because after all, if you're using, let's say if you're using Kubernetes, it's been created by many more people than you. And you could basically trust that scheduling capabilities of it are much better than, for example, of supervisor D that you're going to run inside your container. So do not be afraid to give your processes to the platform that you're running on. Most likely, the processes in here are going to have separate logging facilities. So this means that managing what they're producing is going to be really hard, and it's going to be really expensive to do so. And each of the instance, and you want to run more instances of your application at some point, is going to run the full set of the services. Because, once you start this container, you get a copy of everything. What this means that you're wasting a lot of resources, and this is the easiest thing. I mean, if you're wasting a lot of resources, it's a problem that you can solve with money. But what if you have separate databases in each of those containers? You've heard about the CAP theorem, and there's no way that you can make sure that all of these applications are going to run and are going to be aware of each other, and the data is going to be working properly inside all of those containers. So once you have problems with consistency, you're going to have a bad time with your application. Yeah, and of course, this application as a whole, because we have to consider it a whole application, is most likely going to be stateless, and stateful. And we do not want our applications to be stateful in the cloud, because cloud always changes. Yeah, and as I already mentioned, when you create new replicas of your app, you're going to waste a lot of resources. And, while, as I said, we can solve it with money, we don't want that. So how should we approach this problem? And I want to state here at the start, I know it's not easy, but it's really worth it. And I know that not all of the applications can be handled this way, but we should actually try to do it properly whenever we can. So for a start, each of those components is a container now. And we're running this inside a container platform. So I suppose it's going to be Kubernetes, as is with almost all of the instances right now. What do we get? We get separate, mostly stateless processes, because we extract the state from the main application, and for example, we get a front-end application which just uses external state storage to, run. We can scale front-end to multiple instances and use the same state storage for that, or we can scale state storage separately and make sure that it's coordinated well with other instances. And the processes in here are going to be managed on the platform layer. So, for example, running multiple instances of the same container is going to be managed by Kubernetes. You're not going to have to worry about scaling the application yourself. You can just set up some threshold, and after you reach, for example, the CPU usage, you're going to have a new instance of your application automatically. Each of the external components can be specified as backing services. So if at any point in time you decide that you want to move your state to another system, like, for example, to some managed solution, you don't want to run your own Redis, you want to run it on some managed Redis, you just change the environment variable, switch it to some other instance, and it's happening for you. It's kind of magic, but it really isn't. It's just good design. Of course, the services are still going to be exported by port bindings, so you can access any of them. And this way, we can easily scale our application out by creating more instances. For example, as I already mentioned, we can get more instances of the front end. We can run more instances of the worker processes, and our application components can scale separately if we do it right. And as a bonus, we can have an external logging facility for all of the components, and we can analyze all the information that we have about our system in the same place at the same time easily. So, as you can see, here on the slides, there are those of the 12 factors that we are actually using in this situation. And as you can see, these aren't all of them, but these are the ones that we want to, see that they were applied here. I tried to cover them as I was speaking, so I suppose it should be clear that these are the patterns that we've been using here. All right, but this is just one situation where you're running a legacy application in the cloud. You have to change it and migrate it. But at some point, you're going to run on a greenfield project, which is going to run with some new technologies, right? Not a legacy Java monolith. I'm going to run serverless. I'm one of the cool kids, right? So does serverless actually change anything regarding how the 12 factors apply? Well, this is not the serverless track, so obviously there will be more tracks saying a lot more specifics about serverless, but let's start with a simple explanation of what serverless is and isn't. So first of all, as the name suggests, there are no servers, right? Just put your code in the cloud and it runs. Well, yes and no, you could say. From the perspective of a developer, just run your code. And from the perspective of the operators of the underlying system, I'm pretty sure that there's a lot of work that they have to do, but, well, you're basically paying for the resources that you're using and for the time of those people. So you're not doing this by yourself. Serverless means that you can run your code in the cloud, and it's mostly used for asynchronous event-driven systems. For example, it can be an HTTP service which will just create responses for your request, but it can also be used to handle some event services, event buses, and you can just run your application, and what is the most important, pay only for the time that you're using it, actually. So if your code is not doing anything, you're not going to pay for, uploading it to the cloud and waiting for you. But how do the 12 factors apply here? Well, serverless brings you a little bit different way of thinking about your application. First of all, you're not thinking about running multiple long-running processes. You're thinking about multiple short-running processes, right? You want to handle the traffic that is coming to you, the events that are coming to you, handle them as fast as possible to pay as little as possible, and move on. And if you have more events, you run more instances of the function, it gets handled, and you're ready. So you cannot actually talk about how the processes things from the 12-factor apps apply here, because they're kind of implied. You cannot not follow those rules, right? So let's talk about the ones that you have to follow, you want to follow in here. First of all, you're going to have a single code base with all the dependencies explicitly declared, because there's no other way with the serverless functions. You cannot run, for example, a serverless MySQL server, right? So you have to use some external backing services. You have to point your serverless functions to them and make sure that those instances can be replaced as needed or can be different in different environments. And since we're talking about environments, we can have the same code with different environment variables with the same dependencies running on different environments, which means that we have this parity. So I would say that serverless, in some ways, not a revolution, from the 12-factor apps, but it's sort of a natural evolution of, applying those patterns to your software and making sure that it's, well, good software. So if you have a look here, those that are grayed out are basically are grayed out not because they do not apply, but because you do not have any choice. For the others, you still can follow them or not, but you're most likely going to do that. So serverless is fine. Serverless is not a giant change from what we were doing. I mean, of course, obviously it is. I do not quote me on saying that serverless is not a change. It's a big change. I mean, the way you create your applications, you've been doing it right. You will still be doing it right using serverless. But since we are talking about pushing your code to the cloud, imagine this, that right now your code that you are working on, your proprietary code, not the open source one, is being pushed to GitHub. Right here, right now. Are you scared? Are you thinking about all of your to-do comments that you left or your fix-me's? Well, if you are, then, well, you are a naughty developer, but it's not a problem. I mean, people are not going to tell you that you wrote an ugly code, right? But what people are going to see in your code, I mean, I hope not, but what could be seen in your code is your credentials, your service keys, your SSH keys maybe, or maybe details about your own infrastructure because you hard-coded it in your application for now because it's just testing, right? These are the things that you have to think about sooner than later because situations where you push something to GitHub which shouldn't be there happen more often than you can imagine. And people have already learned that it's a good way of, illegal profit that you can get. But right now, I want to talk about something else, about what happens if you actually want to open source your software. What steps you should take and how the 12 factors can help you with that. Let's start with why would you want to open source for example, your software as a service platform that you created, your great product. Well, you might want to run your platform, or your clients might want to run your platform on their own premises just to test. It can work as some sort of always free tier for your application. So people can just run it, see if it works for them, run it some more, and then decide to go with your hosted solution because you give support, you give more features, and so on. So from the business standpoint, it's often overlooked as a great strategy of increasing the adoption of your software. But if you want to run your own application on your own infrastructure and at the same time want people to run it on their own infrastructure, you have to make sure that all the processes that you're using are up to date and can be given to the clients as is. Because the last thing you want is people complaining to you that your open source software is really badly written, it doesn't run, or your installation procedures are not working simply. But at the same time, you have to be careful to not leak any confidential information, as I've already mentioned a few minutes ago. So how can we approach that? There's this saying, which doesn't sound really good if you translate it, if you think about it, but the saying goes, eat your own dog's food. And what it means is that if you are producing something, make sure to use it. Make sure to be the first tester of what you're creating. If you do that, it's much easier for you to spot any mistakes and see any problems before they get to the clients. It's sort of like, this joke about testing in production, but this is actually not frowned upon. I don't know, double standards maybe? No, well, this applies to for example, my favorite example of this solution is GitLab. I'm not affiliated in any way. I just like the way they do it. So basically, they have this open core model, which means that they're giving you an open source version of their application and allow you to run it on your own infrastructure for free with a little smaller subset of the features, but it's not a subset of features which would not allow you to work with the software. And well, it's a Git hosting service which is composed of many different microservices, we could call it. And the good thing about them is that they create multiple ways to install their software. So they create packages, they create containers, they create Helm charts to deploy those containers on Kubernetes. And all of those ways are based on a single code base. And all of the procedures that are specified by them can be used by their own operators or by your operators when you're running on your own instance. So how do the 12 factors apply here? As I already said, containers are not the only way that they deploy their software, right? Not the only way they share their software, they release it. Well, by having a specific build system which works correctly, which separates the build phase from the runtime phase and so on, and by using a single code base, so these are the 12-factor principles. You can create a product which is really easy to use in many different scenarios. And this is something that we obviously want if we want to open source our software. So once again, the things that are really important in this kind of solution are here on the slide. And these are, again, a lot of the 12 factors. So to wrap this up, well, the 12 factors are just some sort of written assumptions. And as you have seen in those cases that were here on the screen already, we haven't used all of them. And we didn't have to. Well, it's obviously not something that you should follow blindly. There are many cases where not all of the 12-factor apps should be applied to your own application. But it's important to always look at what you're creating through this, through these patterns, right? Because even though you might think that your application is something new and it doesn't follow any rules, it does, or well, at least it should. So it's always good to know the patterns that you can follow to create cloud-native applications. But what I think is more important, you don't have to always worry about, following the strict rules. You don't have to actually think about creating cloud-native software. But you have to think about creating good software. And things like the 12-factor apps and all of the cloud-native principles are ways to create good software. And you should basically not worry about, following the set of rules which is going to bind you. You just have to focus on what you're creating and focus on creating value for your application. Thank you so much.
I have a question. So maybe what is the most important from the 12 factor? Like 3 of them. Like maybe there is some, because 12 is a lot. And maybe there is something like, we cannot focus on, I don't know, logging or something like this, and we can only choose only 3 of them.
Okay, so I will just repeat the questions. What are the 3 most important of the 12 factors if I had to choose? Because 12 is a lot. So I will start with addressing the part where 12 is a lot, because actually 12 is a pretty good number in here, because this is the basis of those patterns. And I've seen a lot of new patterns emerging from the 12-factor apps saying that right now we have to use 18-factor apps, or 20-factor apps, and so on. And in my opinion, you can create more factors based on those 12, but those 12 are kind of essential. And if you want to wrap all the good practices in 12 of those can contain most of the good parts. And about selecting 3 of those 12, I would say that it obviously depends on the situation that you're creating. But me being an ops person, I would specifically say that your application should have declared dependencies, that all the environments should be as similar as possible, and the build, release, run part. But it's obviously because I'm skilled to the CI/CD part. But it would be you could choose 3 of those for another instance, right?